equations. So we have a couple of vocab terms to start us off here. So first of all, we have term. A term is a variable constant or a product of a variable and constant. So pretty much what that is saying is a term can be a variable, so it could be like x or y, a constant, which is just any normal number, like 4, or it could be the combination of the two, which would be like 4x. So one thing with terms is we want to simplify our terms as much as possible. So we can only simplify terms that are like terms. So a like term are terms that have the exact same variables to the same degree. So for example, if I had 3x and 7x, those would be like terms. They both have the variable of x, and both of the x's do not have an exponent. But for example, if I had 3x squared and 7x, yes, they still have the same variable, but the degree is different because one is to the second power and one is to the first power. So these would not be like terms. So like I said, we want to simplify our like terms. That process is called combining like terms. So to do that, I'm going to highlight my like terms. So I've got 4x and 2x, which both have x to the first powers, and then I have y. So combining like terms, I could not add y with my x's. So I'm going to combine them. 4x plus 2x gives me 6x, and then y plus nothing is just y. All right, we'll look at the second example together in class. So steps to solve multi-step equations, very similar to two-step equations. First of all, combine your like terms. Make your equations as simple as possible. Second, just like two-step equations, we are going to move the constant by most likely adding or subtracting. Then we will multiply or divide to isolate the variable. So let's do an example of this. So in the first one here, I have 11m minus 8 minus 6m equals 22. So the first thing I'm going to want to do here is combine my like terms. Remember, you can only combine like terms that are on the same side of the equal sign. So although negative 8 and 22 are like terms, I can't combine them because they're on opposite sides of the equal sign. So instead, I'm only going to combine my m's. So I've got 11m minus 6m, which gives me 5m minus 8 equals 22. Now for step 2, I'm going to try to isolate my variable. So I'm going to move my constant. So right now, I have minus 8. So I'm going to add 8 to both sides. This will give me 5m equals 22 plus 8, which is 30. Now I'm going to undo my coefficient. Right now, I have 5 times m, so I'm going to divide m from both sides. Okay, dividing m here, I've got m equals 30 divided by 5, which gives me 6. Okay, very, very similar process with the one on the right. Give this a try on your own and come to class with questions if you have. All right, on the second page here, we are continuing with this process, although we are bringing in the distributive property, right? So using the distributive property, when we have the distributive property involved, we need to get rid of, and I don't know why it says that. I'm going to change that to the multiplying term. So the multiplying term is just the term that is out in front of our parentheses. So with the multiplying term, we really have two possibilities that we could do. We could distribute the multiplying term, or we could divide it out right away. I think most of you will want to distribute this, so that's how we're going to learn for now. I will show you the division way in the future. So I'm going to multiply in 3. So I've got 18 equals 3 times 2x, which is 6x, plus 3 times negative 6, which is negative 18. From here, let's isolate our variable. So let's add our constant to both sides. 18 plus 18 gives me 36, which equals 6x. Right now, 6 is my coefficient, so I'm going to divide both sides by 6, and that's going to leave me with 6 equals x, or x equals 6. And that's my final answer for that one. Give the example on the right a try on your own, and if you have questions, come to class with them, and we'll make sure to take a look at it. So, just like I warned you guys about already, some of our equations will have fractions. So when we have fractions, there's a couple different ways we can handle these equations, but the most common way to handle these will be to try to combine our like terms as much as possible, or combine our fractions. So for this example on the left, I have 2b over 5 plus 3b over 4 equals 3. So really, my goal at the start here is going to be to combine my two fractions together. So in order to add my fractions, I'm going to need a common denominator. So the least common multiple of 5 and 4 would be 20. So that's what I'm going to multiply with the goal of getting. So 2b over 5, I'm going to multiply that by 4 over 4. And 3b over 4, I'm going to multiply that by 5 over 5. So now multiplying, I've got 4 times 2b, which gives me 8b, over 4 times 5, which is 20, plus 5 times 3b, which is 15b, over 4 times 5, which is 20, which still equals 3. I haven't multiplied 3 by anything. Now that I have a common denominator, I'm going to go ahead and combine my fractions. So, adding my numerators, 8b plus 15b, it's going to give me 23b, which is still over 20, equals 3. So like we talked about previously, when we're working with fractions, typically we want to multiply my denominator to undo my fractions. So I'm going to go ahead and multiply my denominator of 20 to both sides. This will cancel out my fraction, giving me 23b equals 3 times 20, which is 60. Now I'm going to undo my coefficient of 23. 23 times b, inverse operation is division. So I'm going to divide both sides by 23, which just gives me b equals 60 over 23. And since there's no way for me to simplify this fraction, I'm just going to leave that as my final answer. So I know fractions make things a little bit more complicated, but still give the example on the right a try on your own, but we'll make sure to look at it together in class. All right, thanks for watching.